Good morning, everyone. My name is William Isaacs. I'm the moderator for this session, using the US National Grid to create univariate, bivariate, and multivariate gridded maps, a how-to guide by Georgina Strode. It's 10:45. We're going to go ahead and begin our session. So without further ado, here is Georgina.
Hi, can you hear me? Hello?
Yes, Georgina, everybody can hear you.
Okay, I'm going to start a slideshow here. First of all, I want to thank you for your interest in gridded maps, and I'd like to share with you some techniques that are based upon the US National Grid. Now, as you know, the way that we use Choropleth maps forces us to look long and hard at the land area when we ought to be focusing on our map subject matter. So the gridded map can help reveal some of the hidden data patterns in your data, and it can help focus on the subject matter instead of the land area. First of all, there's a lot of information here. We've got a 3-page table of contents. We'll go with why we need gridded maps and why do we need this particular grid, and what we need to use these methods. The grid system has its basis in the military, but it's been co-opted for other uses: search and rescue, first response, and asset naming. And what I'm going to show you today is cartography. So the second part of the presentation is I'm going to show you some GIS function and ideas. You already know all of this because you are at a GIS conference, but you may not know why it needs to be tied into the grid and how it is beneficial. So we'll go over those. And the last part, I'll show you several maps that I've made using a combination of the functions that you saw on the previous screen. We're going to start out with the easiest and then go to the more complex. So this is a map, a population data map provided by Division of Emergency Management. And as you can see, this is another example where data patterns are hidden. So we're going to apply a grid, and then we apply the data, and now suddenly you can see what you couldn't see before. Okay, we have a short quiz here. We have a large area and a small area that each have 100 people. Which has the most? And there are 3 correct answers. The mathematician will tell you that it's equal because 100 equals 100. The graphic designer will tell you that visual weight is the winner here, and we will always see Texas before we see Connecticut. But if you're looking at density, then the smaller area takes precedence. So that is another reason why we need to have gridded maps, so that we can keep our eye on what's important. And you remember the lead crisis in Flint back in 2015? And what they had done is they aggregated their data to the zip code, which is too large of a unit. And you had people in the same zip code getting water from different sources. And when you average bad water and good water, it turns out to be okay water. And so they missed it. But a gridded map, or even a map at a smaller geographic unit, would have caught this problem earlier. Now, why the US National Grid? First of all, it's a standard. It like I said, it has its basis in the military from World War II. It conforms to the shape of the Earth with UTM. It's continuous. And there's a lot of information here, but it's basically the accepted coordinate system for the United States. And it's in the public domain and is free of charge. Okay, I know you're familiar with the UTM, and as you know, that covers the Earth pretty well, and it's measured in meters. So The first step of looking at an identifier is to see what UTM zone it's in. And these three characters are called the grid zone designation, or GZD. Now, once you have found your GZD, then you move to a 2-character gridded system there. And this is so carefully thought out that they don't duplicate for like 800 miles. So you're safe with that. Now, once you go inside this area, then you basically have a series of grids within grids. It's like those wooden nesting dolls. You open one doll, and then there's an identical one but smaller, and you open that one, and so on and so forth. So once we get inside this 2-character region, we really have 5 nests of grids. And the more digits you use to represent your point, the more detail. So 10 digits would give you a 1 meter, 2 digits would give you a 10 kilometer. And some of these, the grid zone identifier and that 2-digit character, the 2 characters, they act like an area code on your phone. So if you know where you are, you can drop those off and just go right with the 2 to 10 digits. What you'll need here, we're not going to go too deeply into the national grid. You basically just need to know that it works. It's been vetted for 75 years for military purposes, and each cell has its unique identifier. And for GIS, here are the functions and tools that you need to know. You will face a file size challenge, but it's not anything that you can't get around. You can work in batches, and you can delete unused grid cells. As far as your personal characteristics, organization is good, and you may need pencil and paper for some of the more complex. So the first use is search and rescue and first responder. And the reason this is because it's a reliable way to locate anywhere on Earth. And here is an example of how street addresses are not necessarily the best. You have 1 building and 3 addresses. Here we have the opposite situation. We've got almost 500 acres, 50 buildings, and 1 address. And this is a true story of a zoo in Apple Valley, Minnesota, where the lion escaped. So the officer looks at his GPS and he just starts reading numbers. So this slide will give you a little more information on how the grid works, but that's not really the purpose of this. I just want you to know that it works. And what I want you to see here is the officer read 8 digits and they identified the lion. They knew where he was. Now, just think, if you call 911, how long are you on the phone telling where you are? So just use that as a reference. Here's another one more closer to home in Orlando. You've got a golf club and 2 places, 1 address, plus so if you're the ambulance driver, do you really know where you're supposed to be going? Now, this is a public service announcement. There are 2 free downloadable apps that you can get to your phone, and you only need the internet 1 time on download, and after that it will work offline. But it can tell you exactly where you are. So I want to stress the importance of downloading one of these, because you can't depend upon lat long. There are 13 formats for lat long, so unless you and your would-be rescuer have already pre-agreed on which format that you're going to use, there's a chance you may not be on the same page and you won't be rescued. Also, you see what happens with street addresses. And if you call and say, I'm at the beach, it's just not safe. So for your safety and your family, make sure that you download one of these apps. The next use of the National Grid is emergency location markers. You may have seen some of these signs in state parks and trails. The one on the left is the more common one, and it's courtesy Shared Geo. If you go to sharedgeo.org, they have a nice program there. You can key in your address and then print at one of these paper markers on your own printer. I have one on my office. If you see the middle one there, this is more vertical and designed to take up less space, like if you were on a bike path. Now the one on the right, that's kind of news to me. It looks, I haven't seen anything like it, but it's printed up in a news story, so it must exist. Cobb County, Georgia has made a very successful trail marking system, and they have a YouTube video that it's only about 3 minutes, but it's definitely worth watching. And here is a map that shows some of the increase in the uses of these emergency location markers. Now, the third topic that I want to talk about is asset naming. And what is an asset? It's anything, well, it's basically all the things that we don't we don't need to think about in our daily lives because somebody else has already taken care of it. So fire hydrants, gas meters, manholes, traffic cabinets, basically anything. And the problem with these items is there are so many that keeping a unique name is very difficult, and groups have tried all sorts of naming conventions, and it kind of gets a little confusing. What's the easiest way to name an asset is to download one of the mobile apps and put your phone on top of it, just like shown in this picture. I believe that the Kennedy Space Center has been using this method since 2007. As far as testimonials go, the Mohawk Valley Water Authority, well, you see the number of assets they have, 700 miles of pipe, tanks, stations, and they had tried a lot of different methods to be able to keep these things straight, and it was disappointing. So Ms. DeGeronimo heard about the National Grid, and she went to use that, and she actually expanded it a bit to be able to handle assets in close proximity and that touch, because pipe fittings will touch one another. Now, the New York Department of Transportation had seen what the Water Authority had done, and they decided to do the same thing with great success. If you're interested more on this, there is a naming handbook, and it actually has some of the thought processes from the Water Authority and from the New York DOT. And there is also some downloadable Python code courtesy of Florida State University available. So now we're going to move to the second part, where we're going to go through the GIS functions and ideas. So first of all, you need to know how to download your grid system. So there is an organization called USNG Center.org, and they have already made shapefiles for everywhere in the US at the 1 kilometer level. And if you scroll to the bottom of the page, they have 100 meter level. So it's just a matter of downloading these shapefiles. They're just empty shapefiles with the identifier. The next thing is Raster versus vector. You already know this, but a raster each pixel can contain one piece of information, but with a vector, there are multiple attributes and you can perform math and statistics. So this gives a lot more flexibility being in a vector. Color, I just want to bring this up, and you can read more about it on your own, but there are concepts for choosing bivariate colors depending on what you want to do with your map. So I'm going to show you examples of these top two on the right side of the page later on. The attribute join. This is so easy with this method because you have your identifier. So all you need to do is match the shapefile that you download from the USNG Center and your data, and it's a very simple join. Summary statistics, this could be your best friend. It's a handy method to do mathematical functions. You see the list there. You can sum, average, count, whatever you want, and the case field will be your USNG identifier. So this is how you say sum all the points for me for this grid cell. The next thing that will find useful to do is a point aggregation. And so if you have points and then you have your grid, what you need to do is assign a identifier to each of those points. And you can do that by spatial join grid to point and performing summary statistics on the point data, like we just talked about. And what you will get there is a CSV file, and you can just join that back to your USNG shapefile. If you want to mix it up a bit and you're not so much into polygons, you can convert them to point. That's another option for visualizing. You can put two together. So anything that you can do with a polygon, and a point, you can do with this method. And here, okay, the file on the left, it looks like it's one map. It's actually three maps superimposed on each other, because styling color and point size at the same time is kind of tricky, and I didn't really trust it. So I divided the points by population into three files. So we have high, medium, and low population, and then you style all three of them. Now the map on the right, this is an election map, and it uses transparency. So transparency applies to the entire layer of GIS. So basically this is 10 files. It was split into 10 files each with a different layer of transparency. So this is another tool you can use. Intersect, you already know this, but I just want to bring it up again, that anything that touches another item is going to be split off into its own. It's like an island. So the thing to remember is if you need to do any geometry calculations, then you need to do that in advance. Like if you need to you need to know the original area of your polygon. Now, do we spatial join or do we interpolate? And there are cases where you would use either one. You see in the example, you've got three polygons that are in one grid. So when you're assigning a value to the grid, which one of these polygons does it pick? And the answer is we don't really know, because I think the GIS just picks the one it comes to first. So the interpolation method might be a little better if you if you need to quantify anything or justify your results or count the votes or whatever it is that you're doing. So with this example, since we do this for the election map, I'll use precincts as an example. We have the fictitious precinct of 1,000 votes. And part of that precinct falls into one grid. And we've measured it and it's 33% of the land area. So we are going to assign 330 votes to that particular piece of intersected polygon. Now we go to the last part where I'm going to show you some sample maps. First of all, let's start with the world's easiest population map. If you're familiar with worldpop.org, they are a group that they use a lot of remote sensing data and asymmetric techniques, and they have been able to make population estimates for anywhere in the world. So that is a very valuable resource, except we need it in a 1 kilometer USNG format. So Dennis Reed has developed this script that converts from WorldPop to the 1 kilometer USNG, and he's in the process of making this available to the general public, but he has to go through all the protocols of his researching it. So when he gets that done and you run his script, you will have an attribute file that has the USNG identifier and a population estimate, and it's a simple attribute join. Here's an example of the results. This is the state of Virginia. As you know, Virginia is in UTM zone 17 and 18, so it's in 2 files. So the takeaway here is that you just have to remember to set your classifications and your colors to be the same for both maps so that you're comparing equally. Another map that we made is a gridded population map, and we took data from the Florida Department of Revenue, the property appraiser data. So this is an alternative approach to the WorldPop, which is top down, but this is a bottom-up procedure where we're looking at the property appraiser data and we assign a population to each land parcel, and then we can do a point aggregation to make the final map. The walkability map. This map is pretty straightforward, really. First, this was commissioned by the Florida Department of Health. The formula that we used has 4 pieces of data: the population counts, which we used from the previous slide, street intersections, which came from NavTech, and the theory behind the street intersection is that shorter streets are thought to be in a more walkable area. So in order to quantify that, all you need to do is count the intersections. The commercial destinations, these would be places that people might want to walk to, that also came from NavTech. And parks and trails, we got from GeoPlan at University of Florida. And in this case, we did a spatial and interpolation on the parks and trails to determine what percentage of the grid is a park or trail. So it's 3 point aggregations and 1 spatial interpolation. And we Z-scored on all 4 of these inputs. And this is the walkability map. There is an interactive map, a link to it at the bottom of the page, and there's a document that describes more about the methods on how this was done. Okay, this is social vulnerability index This data comes from the CDC, and it's a valuable resource for community organizers and planners to see, and emergency managers to see where the pockets of vulnerability might lie in an area. The yellow is the least vulnerable, and the dark blue is the most vulnerable. So the thing with this map is they've taken all the people out of it because of our the way that we have to use the Choropleth maps forces us to look at the land and not the people, when the map subject is really about people. So we're going to do a couple of things and put the people back in the map. So for the data, if you have your world's easiest population map handy, then you already have it in USNG shapefile format, and you already know the population estimate for each grid cell. So you download the SVI data, and you can use a spatial join. And the reason I say that is this map is not going to be quantified in any way. You're really just transferring a rating given by the CDC to a grid cell. So I don't feel that it needs the spatial interpolation, the extra steps there. So then we convert the polygons to points and split the points into the 3 shapefiles like we talked about earlier based on population counts. So you'd have small, medium, and large. And then you symbolize using color and point size. And now you can see where the people are. Okay, here is the election map, the 2012 Obama and Romney. The map on the left is the one they always show us on the news, and there are 2 fallacies with these types of maps. The first one is it's telling you that everybody in the county voted the same way. And miraculously, when you cross the county line, everybody votes the opposite way, which we know is not true. It's also telling you that every county has the same number of votes, which is not true. So we're going to just walk through the steps here. The first is we get the voting election results from the legislature, and we download our shapefile from usngcenter.org. Okay, you already know how to do the areal interpolation. So now what we have here is we have moved from the county to a grid cell, but we still have, we've moved from the false assumption that everybody in the county votes the same way to another false assumption that everybody in the grid cell votes the same way. So we've improved the resolution, but we can do better than this. Okay, instead of saying that everybody in the area voted the same, why don't we proportionalize it according to the percentage of votes? So now you can start to see that basically most people are kind of right in the middle, and you see a few pockets here and there. But now we know that everybody did not vote the same way. But we still are under the misguidance that every area has the same number of votes. So this is the final step, is to split that file into 10 different files based upon the number of votes per grid cell. And you have to reapply the color and apply transparency, and this is the final map. Another way of using this is land use and land cover, which they are two separate entities. The land use comes from your property appraiser or your planner's office, and your land cover would be what you can see from the air. So you can mix and match these if you like. That's another way. It takes a little bit of time to get acquainted with this, but you can, after a few minutes, you know that the yellow in the background is residential. So this is the Tampa St. Pete area. You see that there's a lot of residential in the St. Pete, and the green would be an agricultural. You can even take it a step further and make a chart like this to show the relationship. And you see that we really do have a lot of agricultural land use in Florida. Okay, this is the Florida Water Management Inventory Project through the Department of Health. And first of all, I have to give hats off to LK, Urson, and Liz Sabeth and Michael for their efforts with this project, because this is amazing that anything like this even exists. What they have done is they've gone to all of the land parcels in Florida, and they have determined, is the drinking water public or private, and is it known for sure, or is it likely? So you can see, well, and the same thing for wastewater. So you see that there's a lot going on here. And how do you make a map that can generalize all of this at one time? So what we did is we realized that even though they collect the data at the land parcel, that really the map is about population. And you're saying, what is the percent of population that utilizes different types of water infrastructure? So what we did is we took the data from the Department of Health, and they had if you look at the bottom of the page, the property appraiser data, they had added their water infrastructure data to it. And we know that FSU knows the population estimate for every land parcel in Florida. So why we joined that together, now we can get a better idea of how many people use the different types. Okay, I'm gonna let you read this yourself one day when you have extra time, but these are the steps that went through to make that map. But if you wanted to make a map of this type, it doesn't necessarily have to be that complicated, and you only need 3 fields: your USNG ID, which you have with you at all times, and you make a color code and a size code. And this is really up to you and your method. How do you determine what color it should be? And then you can convert it to the point, split it into 3 files according to the size, and you symbolize. And that's it. Now the last section here is making multivariate glyphs. And basically, you can make any design that you want as long as it fits in a 10 by 10 grid area. And I'll show you how to do some of this. Here's an example of, I ran Puerto Rico. So this is social vulnerability. Let's go in a little closer here. You can see that the glyphs are set, 4 of them kind of offsetting each other. So you can see that up in this area, you see a lot of blue. You know that there is an ethnicity and language vulnerability there. If you see a lot of green, the vulnerability is household composition and disability. And if you see a lot of red, then you know it is socioeconomic. But you can get a sense of how these things interrelate at the same time, and you don't have to flip through 4 different maps. So let's go back. This is Puerto Rico, so you can see the textured look of how things are with that. Now here is the short version on how the glyphs work. And there is a paper that is included with this presentation that will tell you more details on how to do it. basically we are using two sets of grids. We're using the 1 kilometer and the 100 meter. And so this is where we get the 10 by 10 palette. Now each of the 100 meter grid cells, they each have their own USNG identifier, which would have 6 characters in it. But we want to shorten that a bit. So we're going to give it a nickname so that we know how it falls within its parent cell. So for example, the lower left cell is named 00 and the upper right is labeled 99, and everything else is exactly what you would expect in a grid system. So with that, we are going to make a green check on the areas that are good. So what by good, I mean that you can query, you're doing a select by attribute, and you can say if my value is in the top 50%, select that. And then you just select the particular grid cells, the child cells by the nickname. And then you use the field calculator and give it a value, and then you go back in and symbolize it, and that's your glyph. So this is a very simple version, but the paper will give you more ideas on more complex things. If you don't forget about this website, I know I talk about it every year at this conference, but USNG-GIS.org. If you want there are starter data sets that are already made and pre-styled for you, because frankly, it could take a whole afternoon to make some of the color and sizing. So we did that for you. But there's population, land use, land cover, the walkability, and the social vulnerability index that are available for free to download. And like I said, they're pre-styled for ArcMap and QGIS. And if you're not from Florida, you may want to take a look at these anyway, just to see how some of the grids can go together. I made a collection of resources for you that if you want to learn more about this, remember to download the apps and to remind your family the same thing. There's the asset naming. There are 4 cartography papers that use some of these methods. And finally, the last USNG.GIS, where you can download the data sets. And this concludes, I have no idea how I did on time, but this concludes. If anybody has any questions, I'd also like to say, I hope that this has given you ideas on how to make gridded maps on your own. And if you have any problems, you can always call me. And if you make a map, I would be very interested in seeing it, and maybe we could put it on the website. So with that, I would like to close and take any questions.
Thank you, Georgina. You did outstanding on time. We do have about 6 minutes left in the presentation for question and answer. There was a couple of questions that came up about the PowerPoint slides being available for download, and I wanted to make sure that I noted to everyone that they are posted in the chat, and one of the answers to those questions does have the link to Georgina's presentation. And there was a couple of thank yous and kudos on your presentation.
Oh, great.
So if you guys have any questions in the GoToWebinar panel, there is a questions box. All you have to do is type in your question there, and I'll get that and ask Georgina for you. Well, Georgina, it seems like you did an outstanding job, and everybody, well, wait a minute, there we go. We've got one question. What software environment did your team use to create the 10-layer, hold on, to create the 10-layer election map?
That was an ArcMap, and everything was manual on that. And it was basically a select by attribute. If population is under, I don't know, say 400, you write it, just do a data export and write that to a file. And then the next one you'd take 401 to whatever. And so it was really just a manual process in ArcMap.
Doesn't seem like we have too many more questions coming in. Please ask your questions. We'll be here until 11:30 to answer your questions. Also, please see the handouts. There is a PDF multivariate glyph construction using the US National Grid document that Georgina was kind enough to share. That should be in the handouts area of the go-to control panel. I'd like to use this time to thank our sponsors, Esri, Tallahassee Leon County GIS, and Panda Consulting. After this, we have a lunch, and our next session will be starting at 1 p.m. Eastern Standard Time. We have 3 concurrent sessions starting at 1 p.m. And please see the matrix to get the links to those GoToWebinars. Again, thank you to our sponsors, and you all have a great day. Enjoy the SHRUG workshop. Thank you, Georgina.
Thank you.